Alright guys, this will be the second last video where I walk you through a few different types of organic compounds. So today I'm going to cover ethers, acids, and esters. So we're going to start with ethers, which are pretty simple compounds. They have pretty simple structures. They just have hydrocarbon parts and then they have an oxygen in the middle of the chain. Okay, and what that does, when you have an oxygen in the middle of the chain like that, it kind of splits the chain into two parts. And we name them each separately using our prefixes. Okay, and if you'll remember, those are the prefixes there. So if I look at this example I've drawn already, there's one carbon on this side of the chain, okay, which makes that a methyl group. So meth. And then there's two carbons on this side, so that's an F. Okay, and to put these together to make the name of the compound, I'm going to list them alphabetically. So E comes before M, so I'll list this one first. And then I just put a YL on the end of the name. So I'm going to list this one first alphabetically, ethyl. And then this one second, methyl. Okay, so I'm just putting the YLs on the end, and then because it's an ether, I end in that. Okay, so the name of this compound is ethyl methyl ether. There's different ways, other ways you might encounter if you were to look into this on YouTube or something to name this, but we're going to stick with this relatively simple method here. Okay, so this is ethyl methyl ether because we've got a meth part of our chain and we've got an F part of our chain. And we have to list those two pieces alphabetically. If I wanted to make up a new example of an ether, which I'm going to do down here, I can just, this is sort of free reign. I can choose whatever I want. So I know that I need two parts of my chain. So I can pick any two sizes of chains I want. I'm going to kind of limit myself to 8 because I don't want to have to draw anything super huge. But let's say we have propyl and a pentyl, okay? And then those both start with P, so I have to look to the next letter. Pentyl would come first alphabetically. So my name for that compound would be pentyl propyl ether. Okay, and to draw that, I know it's an ether, so it's going to have an oxygen in the middle of the chain. And then on one side, it's going to have 3 carbons. That would be my propyl group. 1, 2, 3. And on the other side, I'm going to have 5 carbons. That's my pentyl group. 1, 2, 3, 4, 5. Okay? And if I had flipped these, if I had put 5 on this side and only 3 on the other side, that's totally fine. It doesn't matter as long as you have one part that has 3 and one part that has 5. And then the last thing I have to do, because I'm drawing a full structure here, is just fill everything with hydrogens, which is going to be a little bit tedious here. But I'm just going to persevere, and it's going to make me really enjoy drawing the skeletal structure in a second. So many hydrogens, all the hydrogens. Now, this is probably the 4th type of compound we've talked about that has oxygen in it. And you might, I haven't explicitly said yet, but oxygen always makes 2 bonds. Okay, so when we're drawing our structures, it's good to kind of remember how many bonds things make. And we've already seen that carbon always makes 4 bonds, and hydrogen only makes 1. And then oxygen, it's always going to make 2 bonds. Okay, so like that right there. Skeletal structure for pentyl propyl ether. I'm going to follow the same order I did here. So I'm going to start with my oxygen. And then I know I'm going to draw out from the oxygen. So that's 1 carbon right there, 2, 3. So there's my propyl part. And then this is my first carbon on the other side. So 1, 2, 3, 4, 5. Okay, so then there's my pentyl part of my chain. Okay, that was an ether. Pretty straightforward, I hope. So, next type of compound we're going to look at, I'm going to flip my page over here, is an acid. Okay, so organic acids are going to have a group that looks like this on them. Okay, and you'll notice this is a little bit like an aldehyde because it takes up 3 bonding spots on the carbon. It always has to happen at the end of a chain. So when I see an organic acid, I'm always going to have the group that makes it an acid at the end of my compound. Another term for an organic acid is called a carboxylic acid. Okay, that's how you spell carboxylic right there. It just means it's an acid that has carbon in it. Now, the reason that we call these acids is because if I mix a compound that has this group in water, this hydrogen right here that's stuck onto the oxygen, it can actually come off in water, okay, and make hydrogen ions, which is the defining characteristic of an acid. You might remember that a little bit vaguely from grade 10 science. Okay, so this is an acidic hydrogen. If I mix a compound that has this piece on it in water, then this hydrogen can break off, which is what makes this an acid. Okay. I would say drawing these is a little bit trickier than naming them because they only have sort of one part to the chain, so they're pretty straightforward to name. I just have to pick a prefix if I want to make one up. Let's see, I haven't dealt with butane or bute yet today, so let's make butanoic acid. Okay, so that's how I name it, butanoic acid. Okay, so you've got your prefix, and then you're going to end it in anoic, and then you're going to add the word acid to the end. Okay, that's the name of an organic acid. Structure of this, so butanoic acid is going to have 4 carbons. That's what bute means. 1, 2, 3, 4. And then on the end of the chain, I can put my acid group, and you'll remember that looks like this up here. Okay, so acid group. So I've got a double bond to oxygen, and then I've got a single bond to oxygen that's also bonded to hydrogen. And then the last thing I'm going to do is just fill up all my bonding spots on carbon with hydrogens. Looks like that. And notice this carbon is already making 1, 2, 3, 4 bonds, so I don't need to add any more hydrogens to it. It's all good. Okay, if I wanted to make a skeletal diagram of this, and remember when you're answering your practice questions, you can switch between structural versus skeletal diagrams, or you can only do skeletal, or you can only do structural. You don't have, they're just 2 options, 2 ways of representing molecules. You don't have to, there's not some situations where you have to use one or have to use the other. So skeletal diagram here, I need 4 carbons, 1, 2, 3, 4. And then I need to put my double bond to oxygen and my OH group on that same 4th carbon, or last carbon. Okay, butanoic acid, done. The last compound we're talking about today, these are esters. These ones are the most complicated looking compounds. They have a group on them that looks a little bit like an acid, but they're also similar to ethers in that they have sort of 2 parts of the carbon chain that we have to name separately. The other cool thing about esters, I'm really sad that it doesn't look like we'll be able to do this lab, but you can actually make esters in the class, like using compounds that we have in the chemical storeroom at school, and they have kind of interesting smells. A lot of smell and flavor compounds or chemicals are esters. We're going to miss out on that opportunity. I'm sorry about that, guys. Regardless, though, let's not be too sad about it. So an example of a name for an ester. So again, I'm going to need 2 different carbon chains. So let's do propyl methanoate. Okay, so I'll explain how I get the different parts of the name in a second. So propyl, it's going to have a 3 carbon part, and then methanoate, it's going to have a 1 carbon part. Okay? So the structure of this, just like with an ether, I have an oxygen in the middle of the chain. And on one side of that oxygen, I'm going to have a 1 carbon piece because of the meth right here. And on the other side of the oxygen, I'm going to have 3 carbons. 1, 2, 3. Okay, just like that. Now, the only other thing I need to include here, the methanoate, so the part of the name that has the O8 in it, I also need to put a double bond to oxygen on the carbon right beside the oxygen, okay? So this right here is my methanoate group, okay? The propyl group doesn't need that extra oxygen, okay? So the part that comes first with the YL at the end, no extra oxygen. It's just the part of the name that has the O8 on the end that is going to get this extra double bond to oxygen group, okay? And then the last thing I'm going to do is fill everything with hydrogens. Okay, so that carbon was making 1, 2, 3 bonds. So I needed one more hydrogen, 2 on this, 2 on this, and then 1, 2, 3 on this one. Okay, skeletal structure for this, once again, I'm going to start by drawing my oxygen. I have a stick coming off to show the methyl. I have 1, 2, 3 to show the propyl. And then the last thing I need is just my double bond to oxygen right there. Okay, so I've got my methanoate piece and I've got my propyl piece right here. Okay, and that's it. So today, or in this video, we covered ethers right there, and then we covered organic acids and esters. Okay, and I'm also going to post some practice questions so you can try naming and drawing some on your own. And just a reminder, great idea to find a scrap piece of paper and make yourself a little chart like this. It's really helpful to be able to kind of move it around to use it to answer questions. Thanks so much.